introduction to tree, and basic tree concepts. Okay, and in case of tree, there are different types of trees. What is among different types of trees? We are going to see binary tree and binary search tree. This is one binary search tree. Binary search tree we are going to see in this tree concept. So what is actually tree? So previous two units you have studied linear data structure, linked list, array, stack, queue. These are all linear data structures. Okay. So in the third unit, you are going to study non-linear data structure. Okay. One of the non-linear data structure you are going to study is tree. Okay. Where you are going to, again, tree is kind of data structure where you are going to store some elements. Okay. Into the memory. Those stored elements are have some relationship with each other. Okay, so why we are saying this tree data structure as a non-linear? Okay, what is the reason to say that this tree data structure is a non-linear data structure? Because one element will have some relationship to another element. For example, this is an example of tree. This is an example of tree. This tree consists of some nodes. So again, a tree consists of several nodes. Here we have A node, B node, C, D, E, F. Okay. So these are all some nodes in the tree. So tree is a non-linear data structure. Okay. Tree represents hierarchical relationship. That's what I said. One node will have some relationship to the other node. For example, when you take this B node, okay, we call it as, here we are saying this hierarchical relationship as parent-child relationship. Parent-child relationship. Here, when you take A and B, this A is called parent of B. So here B is called now child. So this relationship is called parent-child relationship. In some way, these two nodes are connected. Okay, that's why we are calling this non-linear data structure. Okay, this is how they are associated in some relationship. That's all. In some type of relationship. Here, example, we are calling it as parent-child relationship. So that's why tree represents hierarchical relationship between individual data elements. Okay, we'll see the tree properties. So this is an example of tree. Okay, we'll see one by one what are the properties of a tree. A tree is a hierarchical collection of nodes. Okay, so it has some nodes. Okay, so tree terminologies. So this is an example of another tree. You have 14 nodes starting from 1, 2, 3, okay, up to 14. You have 14 nodes. So what are the tree properties? What is it? This is what terminology you have to remember. When you say tree, you have to remember all these things. Just small things only. You have to remember. So what we told, it is a parent-child relationship. When I take 1, this is a parent for 2 and 3. For the node 2 and 3, these are the child to node 1. Okay. So this one acts as a root node for the whole tree. Okay, 1 is the root node. Okay, this is the root node. Okay, and what about the case of these nodes 8, 9, 10, 11, 13, 14? These are all called the leaf node. Okay, so here leaf node is what? 8, 9, 10, 11. So it is at the bottom of the tree where it does not have any child. When you take 8, okay, it does not have any child. Okay, it is not again having descendants. It is not having any nodes. 8 does not have any node. 9, 10, 11, 13, 14. All other nodes apart from this layer, this level, has some nodes. When you take the 1, it has some child, 2, 3. You take 3. Okay, when you take 3, this is having 2 childs called 6 and 7. So what here is leaf node? A node which is not having any other subtree or does not have any child. That is called leaf node. Then internal node. What is internal node? So the nodes other than the leaf node. See, these are all external node. 8, 9, 10. These are all the leaf node. Other than the leaf node, you call it as what? Internal node. So which are the internal? For example, 2, 2, 3, 4, 5, 6, 7. All are what? Internal nodes. Okay, so these are the properties you have to know. Why? Because we are going to see different types of trees. Different among the different type of trees, binary search tree is the important tree where you are going to see the algorithm as well as the coding program. Both you are going to see. Okay, next, path. What is path? For example, from node 1 to 8, from node 1 to 8, okay, what is the path? How will I reach the node 8? If I have the root element, how will I reach the node 8? I will reach by traversing from 1, 2, 4, 8. So the path is called what? I'll show it in the whiteboard. 1, 1, 2, 4, 8. So if I want to know the path to 8, I have to traverse from node 2, 4, 8. Two, comma 4, comma 8. So I have to traverse from 1 to 8. I will go with the path 2, comma 4. Okay. So for example, I want to reach 14. I want to reach 14. So I will, what is the path? 1, 3, 7, 14. This is the path. So there will be only one path in a tree. If I want to reach any node from the root, there will be only one path. There is no other path. If I want to reach 11, there is the only path is that 1, 2, 5, 11. This is the path to reach the node 11. Then siblings. What is siblings? So the nodes which is at the particular level is called the siblings. For example, when you take this node 1, okay, it has 2 childs, 2 and 3. So normal English terms only. So 2 and 3 is what? The siblings. So who is the sibling of 2? 3. Okay. For example, when you take 6, who is the sibling of 6? 7. Okay. It's like brothers and sisters. That's all. Okay. So sibling of 7 is 6. Sibling of 5 is 4. Okay. Next, ancestor. So ancestor is nothing but the previous one. Okay. When you take the node 4, okay, who is the ancestor of this node 4? The ancestor of the node 4 is 2. Okay. So who is the ancestor of 1? When you take the node 1, this is the root node. There is no ancestor for the root node 1. Okay. And what about the descendant node? When you take the root node, okay, who is the descendant? The descendants are 2 and 3. Okay. So these are the terminologies we are seeing. Next, subtree. So what is subtree? For example, when you take this node, when you take this node 1, so it has 2 subtrees. One is left subtree and one other is right subtree. For example, in our case, in this tree, we have only 2 childs. I'll show it. So in our case, this for this tree, we have what? The root node consists of how many child elements? 1, 2, 3, 4. Okay, so 4 nodes, 4 childs are there for this particular node. Okay, so in our example here, I taken this example as what? Only it consists of only 2 nodes. One is 2 and the other is 3. When I tell subtree, okay, for one is what? 2. This whole is a subtree, and the whole, this 3 is the subtree. Okay, for example, in this case, well, how many subtrees are there? 1, 2, I mean this is a whole thing, 2, 3 and 4. Okay, so this is called the subtree. Next, level. Okay, next I will show it diagrammatically in the next slide. What is level? Okay, and next we'll see height of a node. Okay, so height is that, for example, when you take this node 2, what is the height of this node 2? So we have to calculate the number of edges. Okay, number of edges is nothing but this line, a connected line is called as edges. Okay, for this 2 and 4, it is connected with the edges, a line. Okay, for this 4 and 8, connected with the edges, a single it's connected line. Okay, this we call it as edges. We are going to calculate the height and depth based on the edges. Okay, for example, when you take this node 2, how many when you take this node 2, what is the height? How we are going to calculate the height? From the deepest node or the leaf node. Okay, when you take this 2, when you take the node 2, who is the deepest node? Here, this level, 8, 9, 10, 11. Okay, annotation option is here. Okay, when you take the node 2, okay, I'm going to calculate the height based upon the deepest node. So how will I, how many edges I have to go through to reach the deepest node? So 1, okay, 1, this is 1, 2. Okay, and how can I reach the here? Here also same thing, 1, 2. Okay, this is the height of the root, height of the node to the particular node. Okay, for example, I can calculate like this also. What is the height of the root node? What is the height of the node 2 from node 5? I will say 1. Why? Because there is only 1. Okay, I'm going to calculate another thing. What is the height of the node 3 with respect to node 13? With respect to node 13, what I will do, I have to calculate the edges. How will I reach the deepest node? So here I'm not in the deepest node, I just telling directly then specifically the node itself. What is the height of the 3 with respect to 13? So 1, 2. Okay, next, depth. When I take depth, okay, when I take depth, I will calculate from the root node. Okay, for example, what is the depth of the root? What is the depth of the node 8? When I take calculate the depth of the node 8, what will I do? I will calculate the number of edges from the root node. So from the root node, how many edges are there to connect to the node 8? 1, 2, 3. So these are the 3 edges. So the number of edges is 3. So the depth is what?
Okay, sir.
Okay.
So even level.
Level I will tell you in the next slide. I told no. Level I'll show in the next slide with the diagrammatically. Okay, these are the basic things only. Okay, I'll explain. Height, depth, level, I'll explain. Okay. Okay, I'll explain with this slide. I'll explain with this slide. So level I'm telling. So you take this tree example. You take this tree example. So this is a root node. The root node level is 0, level 0. And the others, please be quiet. I have unmuted all. Please listen. Okay. When you take, I'll explain with this slide the height and the depth. So one of the type of tree is binary tree. One of the type is binary tree. In binary tree, we have at most 2 children. Okay. So what we told, when I show in the whiteboard, how many nodes are there for this, how many childs are there for this root node? 4. 1, 2, 3, 4. A node can have any number of children. Okay. A general tree is that any node can have any number of child elements. Okay, this is a general tree. Okay, for example, I can have, this can have what, any number of child. This can 5 childs also it can have. It is a general tree. Okay, so this root node has a 1, 2, 3, 4 childs. Okay, again, when you speak specifically about binary tree, this binary tree is one of the binary tree is one of the type of tree. Like that, we have a binary search tree, AVL tree. There are several types of tree that we will see later. One of the type of tree is binary tree. So binary, from the name itself we can tell binary is 2. Okay, it can have at most 2, not more than 2. If you take any node, it can have maximum of only 2 child elements. Okay, so when you take example, when you take A, okay, it has at most of 2 childs, B and C. It can have either 0, 1, 2 childs, either 0 or 1 or 2. When you take this B, it has 2 childs. It's okay, fine. When you take E, it has what? No childs, 0 childs. When you take this node E, it has no childs. So it can be a binary tree. Okay. So this is what left child, this is right child. And what is called left subtree? The whole thing, child which is left to A is called what? This is what left subtree. When you take uh, who is the left subtree for B? Okay, these 3 nodes. DHI is called the left subtree of the node B. Who is the right subtree of B? This only E. We are talking about binary tree. Keep it in mind. Binary tree, from the name itself, we can tell that it can have at most of 2 children. That's all. Simple. When you take A, who is the right subtree of A? This whole thing. CFG is called the right subtree. Who is the right subtree of C? Okay, since it has only one element, okay, we can say it is a child or the subtree. That's all. So the C has a right subtree of the G. Who is the left subtree of C? This F. Okay, so this is about binary tree, and we've seen the levels. So level 0, the root node is a level 0, and the node which is at the deepest node is the height of a node in a tree is the length of the longest path. Okay. The height of the node in a tree is the length of the longest path from the node to a leaf. Okay. For example, I'll show it. So when I take this node 2, what is the height of the node 2? So which is the longest path? So both are same. When I calculate the, I have to calculate the edges. So 2 to 5, it's connected with the edges. When you take 5 to 10, it is connected with the edges. Okay. When you take this 4 to 5, 4 also connected with edges. So I have to calculate the edges. Okay. When I calculate to the deepest node, I'll traverse from here this way. 1, 2. These are the two edges. So, okay, fine. When I traverse this side, right side, okay, I'm calculating the deepest node. I'm calculating 5, 10 and 5, 11. Both when I take everything, every edges are equal. When I take traverse this side, also this is two edges. When I traverse this side, 2, 4, 8, 9, also two edges. 2, 5, 10, also two edges.
Yes, sir.
Okay. So this is an tree I have taken. Okay. This is one. I want to calculate the height. I want to calculate the height for this node 1. Okay. What will I do? I will traverse to the left side as well as right side. Okay. I will traverse up to the deepest node. Okay. When I will traverse this side. For example, one edge is there, 1, 2, 3. So here it is 3. This side is 3. And when you take this side, I will calculate the right side also. It is having 1. So which is highest? So this 3 is highest. Okay. Now I say the highest 3, 4. Okay. When I take this node 2, okay, I want to know the height of the node 2. What will I do? I will traverse this left side. How many childs this 2 is having? Only 2 childs. This side, one child is 3, other child is 4. Okay. 5. So what is the height of the node 2? Okay. So I'm going to see the depth. I'm going to see how far I am deep from the what some ground level, right? How will you say depth from ground level? How far you are from, how far you are deep? Okay, the ground level is 1. Consider that the ground level is 1. Okay, I want to calculate the node 11 deep depth. Okay, what I told, how far I am from the ground level. Okay, so when you take ground level, again I will calculate the edges 1, 2, 3. For the node 11, the depth is 3. Why? Because how will I reach the, how far I am from the ground level? From the root node. 1 edges, 2 edges, 3 edges. This is the depth. Okay. When you take 6, for example, and you take the node 6. Okay. How far I am from the ground level? 1, 2. Okay. You are in deep. Okay. So 1, 2. So the edges is 2.